Okay, folks, let's talk about chapter 4 in Dale Dubin's book. Now we're going to talk about calculating the rate. How are we going to start to do this? So, this is going to be the first thing that we want to start thinking about. And when we're examining these EKGs, definitely something that's going to be important because it's going to determine what rhythms we might be selecting, specifically for our sinus rhythms. So when we're reading these EKGs, we're going to read in cycles per minute, or kind of what we discussed on day one was reading beats per minute. And that's how we actually calculate what the heart rate is. The heart rate's um, going to be calculated in beats per minute, right? Those are the units of measure for measuring the heart rate. Just like in our book, we're going to read from left to right, but we want to make sure that we're reviewing the entire strip before we start making a decision or starting to even identify where we're going to start making our calculation for our rates. We're also going to discuss the intervals that are within the EKG. Right, we're going to take a look at the PR interval, the QRS interval, and the QT interval. So first, before we calculate these rates and we calculate these intervals, we're going to have to identify them a little bit closely. Okay, our PR interval, that is the beginning of the P wave to the beginning of the QRS complex. So if I have a P wave like this, and then I have a QRS complex, that means it's from here, where it starts to go up from baseline, right, to right here, right where the QRS complex starts. This is going to be my PR interval. Now, a normal PR interval is going to be between 0.12 to 0.2 seconds. Now, what does this all mean? What does the PR interval mean? Well, that's the time that it takes for the stimulus that originates from the sinus node to go all the way through the atrium and make its way to the AV node. Okay, the next interval we're going to talk about is the QRS interval. The QRS interval. Now, the QRS interval is the total time that it takes for the stimulus that arises from the SA node, depolarizes the atrium, makes its way down to the through the AV node, through the bundle of His, the right and left bundle branches, and out the Purkinje fibers. This is the total time that it's going to take to ultimately spread that stimulus to depolarize all of the ventricles. That normal QRS interval is going to be from 10 to 0.10 to 0.12 seconds. And that's going to be from the beginning of the QRS, whether it goes up first, okay, or down first to the end of the QRS when it gets back to the baseline. And then our QT interval is the time for the return of the stimulated ventricles to become back to rest. So the time for return of stimulated ventricles to rest. Okay, so ultimately that means the total repolarization of the ventricles. So here's our close-up look, beginning of the P wave to the beginning of the QRS. That is our PR interval. QRS, the beginning of the QRS to the end of the QRS. That's our QRS complex. And our QT interval is actually the beginning of the QRS to the end of the T wave. Right in there. So that would be our QT. There it is right here, our QT interval, our PR interval, and then our QRS interval, our QRS complex. You're going to notice that the QT interval is going to change based on heart rate. So the slower your heart rate is, the longer you have a QT segment. The faster your heart rate is, the shorter that QT segment. So there's an inverse relationship between the rate at which your heart goes and the length of your QT interval. Slower it is, the longer your QT interval, right? And this makes sense too, because as we start increasing our heart rate, we need to repolarize faster. Well, remember that QT interval is pretty much saying the total time it takes for your heart, your ventricles to contract and then return back um, to polarization so that they're ready to contract again. That's what that QT interval really refers to. All right, so we're going to start talking about these sinus rhythms. Okay, we kind of identified a little bit about them a little bit earlier in the lectures. We started talking about our inherent rates. Right? We have the sinus node, right, the SA node, and it likes to pace between 60 to 100. Okay, then we have atrial cells, 60 to 80. Junctional cells, 40 to 60. And ventricular cells, 20 to 40. Okay, now what's important to remember here is what this is saying is that because of this term automaticity, that says that any cell that's located in the atrium, junction, or ventricle has the potential to create a rhythm. And if it does create a rhythm, it will pace within these ranges. However, if we have our sinus node firing, okay, there are special characteristics that will help us identify that, right? And it typically beats between 60 to 100 beats per minute. However, if it does not beat between 60 to 100 beats per minute, it's going to be classified as a different sinus rhythm. Okay, so when we have the sinus node pacing between 60 to 100, we call it normal sinus rhythm. Okay. Now, there's certain things that need to be true for us to identify sinus rhythm. Well, if it's sinus rhythm, remember, it originates in the atrium, specifically the posterior upper wall of the right atrium. So when a signal fires, it depolarizes both atrium. And whenever we get depolarization of the atrium, we get a P wave. So sinus rhythms must have P waves. Okay. Once that signal goes through the atrium, it then arrives out to the AV node, passes through the AV node, but before that happens, we see a small pause in conduction, which is that flat line that we see after the P wave, but before the QRS complex. When we see the QRS complex, that tells me that the signal has gone through the AV node, down the bundle of His, into the left and right bundle branches, and then out of the Purkinje fibers. And when that happens, we get contraction, where blood will move out of the ventricles and either towards the lungs or out to the body, because we get ventricular contraction at this point. So we will see a QRS complex. A QRS complex. And then finally, we'll see our T wave, which is our repolarization of those ventricles. Now, when the sinus node is firing, it's going to fire between 60 to 100 beats per minute, hopefully. And if all of these things are true, where we have a P, a QRS, and a T, then we're going to deem it normal sinus rhythm. Now, the differences between normal sinus rhythm and our next rhythm that we're going to talk about, sinus bradycardia, All of this is true here where we have a P wave, a QRS, and a T wave. However, this term Brady refers to slow. Okay. Slow refers to less than 60 beats per minute. So 59 and below is going to be classified as sinus Brady. However, in order for it to be sinus Brady, all of this must be true where we see a P wave, a QRS, and a T. And it's really important that you understand that with every single heartbeat that we come across, we should see a P, a QRS, a T, a P, a QRS, and a T, a P, a QRS, and a T. And all of those P waves should have the same or very, very similar shapes. And if they do, then we love calling it sinus. How do we identify whether it's normal sinus or sinus Brady? Based on the rate. 60 to 100 is normal sinus. Less than 60 is Brady. And we abbreviate normal sinus with NSR. Okay. So what happens if it goes faster than 100? Well, then we call it sinus tachycardia. Because I have a little bit more space here down below, let's draw a quick sinus tachycardia. Okay, so this is fast. Let's just call it fast, and let's say it's 105 beats per minute. And we'll call this one tachy, sinus tachy. As opposed to sinus Brady, which would look something like this. A lot slower, a lot more space in between each QRS complex, between our R to R. Well, if we remember our recording paper, what was on the x-axis? Always time. So when you look at these two, right, there is more space or more time down below in sinus Brady. That's because the heart has more time in between each beat. Right? Ultimately means it's a lot slower rhythm. So just to go back to what we were talking about earlier, where we have our SA node, we have our atrial cells, our junctional cells, and our ventricular cells, we must remember to familiarize ourselves with the rates at which they pace within their given areas. So we know 60 to 100, 60 to 80 beats per minute, 40 to 60, and 20 to 40. And we've talked about this ranking system or pecking order. And that's what this is up here. The sinus node always is going to have priority to pace the heart. Why? Because it has the most variation at which it can pace, and it can pace at the highest rate, 60 to 100. That's great. Okay, that's what we're looking for. So, what happens if the sinus node fails to fire? Fails to fire. Well, we got to remember that term automaticity. Right? Automaticity refers to the ability of any cell in the heart to create a rhythm. Any cell that's other than the sinus node can fire and create the rhythm. It will resume or assume pacing as the dominant pacemaker. If this occurs, We'll call this an ectopic or abnormal focus. Okay. So when the sinus node fails to fire, atrial cells, atrial cells can fire, junctional cells, and ventricular cells. They all have the opportunity to fire if the SA node does not. So say the SA node fails, well, will it be the atrial? Okay. If the atrial does not fire, the next one in line that has the priority is the junctional. And if it doesn't fire and start pacing the heart, our last resort is our ventricular cell. Okay. If that fails, you're dead because now your heart will not beat. At any point in time, any one of these cells can take over. So you might have a ventricular cell firing, then all of a sudden the sinus node can turn back on. Or another cell of a higher order. Another cell of a higher order may wake up and then start resuming the pacing of the heart. Okay. So these are your inherent rates. This is your order of pacing for the tissue within the heart. All right. So what we just finished talking about with these other cells and their ability to fire is this idea of overdrive suppression, where rapid automaticity suppresses the lower, meaning the sinus node, when it is on, it will not allow these other ones to turn on. So as the sinus node fires, it suppresses the atrial, junctional, and ventricular cells from firing. However, they're not just ignored the entire time. They are useful for this emergency backup that we kind of talked about just a second ago. If the sinus node fails to fire, we have emergency backup pacing, and that is our atrial cells. Junctional cells and ventricular cells. So that's it. Just if backup pacing is needed, that's what's going to happen. All right. So with absence of pacing from the sinus node, an atrial cell will pace between 60 to 80 beats per minute. In the absence of pacing from a sinus node, so absence of pacing from the atrium, which includes the sinus node, right? Sinus node and atrial cells. Then a junctional foci or cell will take over pacing and paces between 40 to 60. Only occurs if the SA node and all atrial cell fail. Okay. We have another term for this. It's also called a complete AV block conduction, which we'll talk about later in chapter 6, I believe, chapter 6. Now, if the sinus node fails, atrial cells fail, junctional cells fail, our last result are cells within the Purkinje fibers or ventricular automaticity foci. Okay, and they are surrounded in the bundle of His, the bundle branches, down in the Purkinje fibers, and all the other subsequent branches within the ventricular electrical system. They can then pace between 20 to 40 beats per minute. But again, it has to occur only when all other cells above at higher order fail. Okay, so now that information was extremely important because we're going to start seeing different types of strips, different type of EKG beats, and we're going to need to be able to determine what kind they are. So that's important to understand is those different cells from either the sinus node, the atrium, the junction, or the ventricles. They have different rates at which they will fire, and they will pick up at different times based on the failure of those um, higher order cells. Okay, and we're going to determine some of the criteria that needs to be met in the next chapter. So now the first step that we're going to do is we're going to check for regularity. Now, when I say step one, the reason I say step one is because with the way we're going to approach this, we're going to approach this as a playbook, right? So this is going to be our playbook, right? Or think about like a recipe, right? So I'm going to help you guys develop this playbook. That way you can make sure that you follow procedures to make the best assessment and the best analysis of an EKG. The first thing we're going to do is we're going to do step one, which is check for regularity. Now, what does regularity mean? Regularity means consistency. Regularity means predictability. Okay. If you think about music for just 1 second and you think about maybe a good song that you enjoy, there's a tempo at which um, the beat will go ahead and play. Right. So if you've ever taken a CPR class, they say you should do compressions at 100 beats per minute. And they say, you know what, if you're not sure what that is, start singing Staying Alive by the Bee Gees, which has a tempo of 100 beats per minute. So 100 beats per minute. Okay. So the important thing about here is we know tempos are regular, right? They don't go off tempo, right? They will sound really weird, I'm sure, because that's like going off rhythm. Okay, so that's something we want to check first. We want to determine if we have a regular rhythm or an irregular rhythm, right? And again, regularity just refers to predictability and consistency. Okay, so that's regular and irregular. When we're talking about normal, abnormal, sinus rhythms are normal because they have a P, a QRS, and a T wave. All right. But we have to go a little bit further. That P wave will have to look the same in every single beat. And at the PR interval within normal range. So normal range PR and consistent P shape. And then the QRS needs to be within normal QRS interval. Okay. And the T wave must be present. Must be present. Okay. When you have an abnormal beat or rhythm, some of these things are not going to be available. So let's talk about calculating the rate. So here, we're going to start with one of our three methods that we're going to cover. So I have a sample EKG here on the screen, and the first method I'm going to show you is what we call the triplicate method, or the rule of 300. You'll hear me refer to it as the 300 method. Okay, so within the 300 method, what we're going to do is we're going to identify specific numbers. I have them outlined here on the left in different colors. So the first number is equivalent to 5 small boxes. The second number is equivalent to, well, 10 small boxes. The third would be 15, then 20, 25, and 30, all small boxes. So for the triplicate method, what you need to do is you need to ensure that the associated number of small boxes is the same value that you're going to apply to it. All right, so what we're going to do here is we're going to select a QRS complex, right, that lands on one of these heavy dark lines. Now, what's the reason behind that? Well, because between each heavy dark line, I know I have 5 boxes. So it's for convenience that we want to find a QRS complex that lands on a heavy dark line or pretty darn close, because then it's easy to count by 5. And what we're going to do is we're going to start at 1 QRS and we're going to count 5 boxes. And the idea is if the next QRS lands on one of these numbers, then we can estimate what the heart rate is. So let's go to this example right here. So if I start here at the blue line and I count 5 boxes, that red line is stating my heart rate would be 300 beats per minute if my QRS complex was right there. But it's not, so I will continue to count another 5 boxes. So now I go to the next marking, and that's 10 boxes. So what that's saying is if this QRS landed right here, then that would be a rate of 150. But it did not. So we're going to go again. So we'll move another 5 boxes. And another 5 boxes actually lands past where that QRS is. But again, this rule or strategy says if that QRS landed 1 box back off to the right or a little bit slower, then that would be equivalent to 100 beats per minute. So now I don't have an exact heart rate right now, but what I do have is an estimate of my heart rate being between 150 beats per minute and 100 beats per minute. So at this point, I'm going to estimate how close it is to 100, because since it is closer to that yellow line, I would say it's closer to 100 than it is closer to 150. Maybe I'll make a guess and I'm going to say that is this heart rate using the 300 method is 107 beats per minute. Okay, so that's how we use the 300 method. So the next strategy and the next method is called the 6-second time period. What we're going to do is we're going to count the number of complete cycles or complete heartbeats within 6 seconds. Well, how do I get 6 seconds? I could do some basic math because I know that each small little box is 0.04 seconds. Each large box is 0.2 seconds. I can make a quick calculation, right? So that means if I want 6 seconds times 0.04, right? I'm going to have to get 100 and what is that? 150 small boxes. Okay, something like that. I think it's about 150 small boxes. And if I want how many large boxes within 6 seconds, okay, I'm going to do 6 divided by 0.2, and I'm going to get 30 large boxes, 30 large boxes. Okay, so 6 divided by 0.04 gives me 150, and then 6 divided by 0.2 gives me 30 boxes. The other thing you could do is you can look on your EKG for these markings. This is a 3-second marking, and this is a 6-second marking. So that means if I'm going to use the 6-second time period, I'm going to count the number of complexes within my 6 seconds and multiply it by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times 10 equals 110 beats per minute. Again, not as accurate, but we're not guessing like we were in the triplicate method. And finally, what we're going to do is we're going to look at the 1500 method. And what we're going to do here is we're going to find two QRS complexes that are back to back. And we're going to count the number of small boxes between the R waves. And then we're going to divide that number into 1500. Again, make it easy on yourself and find one that lands on a heavy dark line. This one's pretty close, even though I put the arrows here already. That's fine. So we got one box in, so we got 5, 10, 11, 12, about 13 boxes. Okay, I think that's about right. 12, about 13 boxes or so. Let me see. So now what I'm going to do is I'm going to get my calculator and I'm going to put in 1500 divided by 13. 1500 divided by 13, and I get 115 beats per minute. So 1500 divided by 13 boxes equals 115 beats per minute. And those are your three methods. Okay. So certain things that we need to consider is when we have a really slow heart rate, a really low bradycardia, okay, we really cannot use the triplicate method because our triplicate method, the lowest heart rate we're going to get is 50 beats per minute. Okay, so what you can do is you can use the 1500 method, or you can use the 6-second or 3-second marking. All right, so if you use a 3-second marking, instead of multiplying by 10, you would multiply by 20 because you need to get to 60 for 60 seconds in 1 minute, because remember, we're beats per minute. Okay, so here's your playbook. Here is the steps that you're going to need to start to memorize and understand to start calculating and analyzing these EKG strips. First thing is checking for regularity. Checking for regularity is important because that's how we're going to be able to identify the rate. Okay, but it's also important in identifying other rhythms. We're going to go back for just 1 sec because I need to add something here. If you have a rhythm that is considered irregular or offbeat, kind of like what we were talking about, okay, then you cannot use the triplicate method or the 1500 method. Okay, you can only use the 6-second method. So I'm going to make a quick note up here. 6-second method for irregular strips only. You can use the 6-second method for regular, but you can only use the 6-second method if you have an irregular strip. So we didn't get a chance to really talk about irregular strips or regular strips and how to calculate it quite yet. But when we're looking for regularity, so we'll talk about it now, what we're looking is to find the distance between the QRS complexes. So we're going to have to count the small boxes. So I have 5, 10, 15, 13 and a half boxes here, 13.5. If I have a regular rhythm or a regular strip, that means I should have 13.5 here, 13.5 here, 13.5 here, all the way across. Now, if I do have 13.5 all the way across, or whatever that number is, however many small boxes, then we have a regular rhythm. our regular strip. Okay. And if we have a regular strip, that means I can do um, every single one of these methods to calculate the rate. So if I do the 6-second method, there's my 6-second markers. Okay. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 beats per minute. 11 times 10 gives me 110 beats per minute. Okay. And then you would do the same thing with the triplicate method. So let's erase a little bit of this here. 300, 150, 100's here. That's about halfway between 100 and 150. Let's call it 125. And then the 1500 method, 1500 divided by the number of small boxes, which was 13.5. And that gave us 115 beats per minute. Okay. So we're going to go over these other ones in class, and I will then have some practice rate strips for you to start participating in, to start getting a little bit more exposure. Okay, I hope you're able to follow along. If not, review the video again. And if you have questions, we'll love to hear them in class, and then we'll go over some of these strips. All right, thank you very much. Have a good night.